Hi, welcome to solveandgo.com. Today we're going to give a video about a couple of linear algebra topics, systems of equations, row reduction, and inverse matrices. So here I'm going to introduce a system of equations and show you how you can solve it using either row reduction or inverse matrices, introducing certain key topics along the way. Okay, so let's work with a simple system of equations, two equations and two variables. 2x plus y is 5. 3x plus 4y is 15. Okay. So, first of all, one method for solving such a system, as you've seen in a high school course, is to use substitution. Okay, this isn't linear algebra. It's something you learned, again, in high school or before. And how does this go? Well, let's label these equations here. Equation 1 and equation 2. Okay, so from equation 1, say, we can solve for y in terms of x. So y is 5 minus 2x. And then what we do is we plug this into equation 2. Okay. And what you get is, okay, so here I'm going to write equation 2 with this new equation 1 plugged in. What we get is 3x plus 4 times, now 5 minus 2x instead of y, equals 15. And then solving for x. So we have 3x here, and then minus 8x. So we write this all out. 3x minus 8x equals 15. 4 times 5 is 20 on the left-hand side. Bring that to the right-hand side, and it's minus 20. I'm going through this a little quicker because I'm assuming you're more or less familiar with this. And okay, so we get on the left-hand side, negative 5x equals, and on the right-hand side, negative 5, giving x equals 1. Okay, so we've solved for x, and now we can just get y by plugging into what's up here. Let me write this in green just to differentiate it. So y is 5 minus 2 times 1 is 3. Okay, so we have x and we have y. All right, that was the method that most of you already knew. Excuse me. This method works fine for a small number of equations and a small number of variables, but it doesn't work very well for a larger number of equations and a larger number of variables. So even if you try this with a set of 3 equations and 3 variables, you'll see it's quite a bit of work. And as you get higher, this amount of work just increases more and more. So what's a more general and systematic approach? Well, we're going to use matrices. So assuming you know a little bit about the way vectors work, what can we say up here? Well, first of all, we have 2x plus y. We know its value is 5 for our solution, x and y. And we have 3x plus 4y, and we know its value is 15. Okay, so now we can separate this vector on the left into 2 vectors which look like this. Okay, this is using properties of vector addition and multiplication. Okay, so now suddenly we have an equation of vectors. And in fact, knowing a little bit about matrix multiplication, which I'm not going to go over in this video, what you get from this bottom equation here is the following matrix equation. Okay, you get 2, 3, 1, 4 times x, y is 5, 15. So now we have an equation of matrices. Okay, and I'm going to write it like this. I'm going to use big X to denote the vector containing little x and little y equals b. So this is a general, these are just letters generally given to matrices in this form. Okay, so here we have A. This is the solution we're looking for, x, and this is the vector b on the right-hand side, containing the constants in the equations above. There are a couple of ways, given this matrix A and this vector b, of obtaining the solution x, y. The first one I'm going to go over is what's called row reduction. And in fact, both of the methods I'm going to go over today both involve row reduction, just used in slightly different ways. Okay, so what's the first step? The first step is to create the augmented matrix. Okay, so I'll show you what this is. The augmented matrix for this system looks like this. 2, 1, because of the 2 and the 1. Then we're going to put a line here to represent the equal sign. 5, and then 3, 4, 15. Okay. So now, to get the solution set, we use what's called row reduction. So there are certain operations on rows that we can perform that won't change the solution set to the matrix we're dealing with. Okay, so what you can do quickly is you can switch rows. So I'll go over row operations in a separate video, but let me remind you what's allowed. Row I can be switched with row J. One row can be multiplied by a constant. Okay, so some number times that row. And you can also take a row and add to it a constant multiple of another row. Okay, plus C times RJ. Okay, so you can switch rows, multiply a row by a constant, or take a row and add to it a constant multiple of another row. Okay, so using these row operations, we want a systematic approach to find a solution to this system of equations represented by this augmented matrix. Okay, so I'll ask you to write down these row operations if you don't already know them. And I'll go through the procedure for finding the solution set. So what you want to do is work from top to bottom and then left to right to begin with. And the idea is that we're trying to make 0 entries under what are going to be called leading ones. So I'll show you what I mean. Here, we want to clear this 3 and make it 0 by adding to this row some multiple of the row above. So to simplify things, I'm going to get a common multiple of 3 and 2, which is 6. Okay, so this involves multiplying the top row by 3. Okay, so we take row 1 and we go 3 times row 1, and then we take 2 times row 2 to make a 6 in either case. Okay, so what we're left with is 6, 3 times 5 is 15. And on bottom here, we have 6, 8, and 15 times 2 is 30. Okay, we did this because now we know we're allowed to take one row and subtract another row from it. Okay, so this was the operation of taking a row and adding a multiple